Environmental Science, Chapter 15, Water Pollution, Video 1. People have dumped waste into water because it's quickly dispersed and diluted. Polluted water is unusable for its intended purpose. Similarly, contaminated water is water unusable for drinking. Water pollution is highly costly. It's costly in effects it has on the health of people, other organisms, and ecosystems. And it's also costly in terms of economic damage it inflicts on industries, including agriculture. The magnitude of water pollution is quite large. Most developing nations do not have widespread modern water treatment plants, causing about 1/3 of the world's people to have inadequate sanitation. In the US, about 10% of streams, rivers, and bays are significantly polluted. Also, about 1/4 of the groundwater in the US is contaminated and unsuitable for drinking. Natural systems tend to purify water on their own. The water cycle takes water that's been polluted, evaporates it up into the clouds, where the pollutants often are not transported with it, and then rains it down onto the ground. Water then is filtered through sediments and groundwater and aerated in the process, allowing bacteria to break down any organic contaminants. Purification of water in liquid form usually depends on natural filtration, chemical absorption, and absorption by soil particles and organic matter. Also, living organism uptake of nutrients and living organism decomposition processes in the soil and water environments. Human activities that compact soil, degrade soil structure in other ways, or contaminate stormwater with pollutants, or even alter the composition of soil and water-based organisms, eventually reduce or retard the natural purification processes and cause accelerated movement of unfiltered water through the system and into our water supplies. Soils, especially in wetlands and riparian areas alongside rivers, along with the vegetation and the microorganisms that live there, play very important roles in natural water purification. Microorganisms in soils, wetlands, and riparian areas either utilize or break down numerous chemical and biological contaminants in water. In some sense, pollution is the overwhelming natural purification systems. As the human population and per capita use of water both increase, natural water for purification processes have been overwhelmed in many areas. Water pollution can be classified in 3 ways: by its composition, its source, and its ultimate fate. In this table, we break down the main types of water pollution. There's pollution that causes oxygen demand in the water system. These are types of organic materials that, when broken down by bacteria, cause the oxygen to be driven out of water or used up. There's pollution that's infectious agents from bacteria and viruses. Usually this comes from waste streams, either from animal waste or human waste streams that get into water. There's organic chemicals like pesticides and herbicides and detergents. And there's inorganic chemicals like acids from coal mine drainage, or all the metals that also leach out into the water system from acidified waters. There's sediment for land and erosion, clay on stream beds, which may produce or even destroy life forms living at the solid liquid surface, and or just water being clogged up and not allowing light in so that photosynthetic organisms can grow. And there's radioactive substances, either from mining or from well drilling in Maine, such as radon. And heat too can be considered a pollution if it affects, if the cooling towers affect water microbes in the area. Let's take a look at biological oxygen demand. Pollutants that demand oxygen from the water stream are called pollutants that induce biological oxygen demand. In a stream, system both produces and consumes oxygen. It gains oxygen from the atmosphere and from plants as a result of photosynthesis. Running water, because of its churning, dissolves more oxygen than still water, such as that in a reservoir or behind a dam. Respiration by aquatic animals, decomposition, and various chemical reactions consume that oxygen back. In general, only about 9 milligrams of oxygen can be dissolved per liter under optimal chemical conditions. Wastewater from sewage treatment plants often contains organic materials that are decomposed by microorganisms, which use oxygen in the process. The amount of oxygen consumed by these organisms in breaking down the waste is known as biological oxygen or biochemical oxygen demand, or BOD. A discussion of BOD and how to monitor Other sources of oxygen-consuming waste include storm water runoff from farmland or urban streets, feedlots, and failing septic systems. Oxygen is measured for BOD in dissolved form as dissolved oxygen, or DO. If more oxygen is consumed than produced, dissolved oxygen levels decline, and some sensitive animals may move away, weaken, or die. Dissolved oxygen levels fluctuate seasonally and over a 24-hour period. They vary with water temperature and altitude. Cold water holds more oxygen than warm water, and warm water holds less oxygen at higher altitudes. And water holds less oxygen at higher altitudes. Thermal discharges such as water used to cool machinery in a manufacturing plant or a power plant raise the temperature of water and lower its oxygen content. Aquatic animals are most vulnerable to lower DO levels in the early morning on hot summer days and when stream flows are low. What are some of the sources of water pollutants? Virtually all human activity produces some kind of environmental disturbance that can pollute adjacent water. The three major sources or categories of pollutants are industrial, agricultural, and domestic waste. Industrial pollutants include effluent from manufacturing, power generating, mining, logging, and construction, as well as food processing industries. Agricultural pollution is usually from a so-called non-point source, while industrial and domestic pollutants are point source discharges, where all the pollutants come out of a point or a tube. Stormwater and rain and snowmelt that runs off pavement and rooftops or other impervious surfaces is the most common cause of water pollution, and these are non-point sources and often hard to pinpoint or control. So let's review. In this section we talked about how contaminated the surface and groundwater is in the U.S. in general terms. We talked about how natural purification can occur. What are the different types of water pollution? We discussed biochemical oxygen demand and what are the sources of it and how it works. We also talked about the major sources of water pollution and what the difference is between a point source versus a non-point source pollutant.